In this video, we'll walk through the critical aspects of laser safety in semiconductor and industrial equipment. If your product uses lasers, understanding the evaluation process, applicable laser safety standards, and proper risk analysis is essential for achieving compliance with requirements like CE mark, UL certification, and other NRTL approvals. Laser systems introduce serious hazards that must be addressed early in the design process. These include direct exposure to laser radiation, reflected or scattered beam exposure, and secondary hazards such as heat, electrical risks, and airborne contaminants. Most laser systems fall under IEC 60825. Which is the primary laser safety standard used globally. As part of the evaluation process, a detailed risk analysis must be conducted to determine the level of hazard and required control. One of the most critical aspects in industrial equipment safety is the beam path. You need to account for intended beam paths, reflections from optical components, and unintended beam paths caused by failures. From a mechanical design standpoint, beam containment is typically achieved by electrical enclosures, machine tool enclosures, or sealed optical paths. These designs must align with standards like IEC 60204 and NFPA 79, especially when integrated with electrical systems. For higher class lasers, safety interlocking systems are not optional, they are required. These systems should shut down the laser when access panels are opened, integrate with lockout-tagout procedures, and support hazardous energy isolation during maintenance. Interlocks are a critical part of compliance with UL standards IEC 61010 and UL 61010. Protective housing plays a major role in both radiation containment and fire prevention. Materials used in enclosures often need to meet UL 94V0 flammability ratings, flame test requirements, and fire risk assessment criteria. This becomes especially important in environments involving flammable gases, pyrophoric materials, and high-energy laser applications. Laser processes can generate fumes, particulates, and chemical byproducts. This is where industrial hygiene and environmental considerations come into play. You'll need proper ventilation systems, exhaust ventilation for hazardous emissions, and controls for chemicals and gas and chemical delivery systems. Failing to address these can impact both safety and compliance. Laser systems are not just optical systems, they are also electrical systems. Compliance often involves IEC 61010, UL 61010, and IEC 62368, protection using circuit breakers, fuses, and other current protection, and ground fault circuit interrupter or GFCI devices. Proper integration ensures the system meets both electrical standard and functional safety requirements. To bring your product to market, certification is critical. This may include CE mark for Europe, UL certification or NRTL approvals for North America, and ATEX certification for explosive environments. You'll also need complete documentation, including manuals, documents provided to the user, and safety labeling and warnings. This documentation supports the overall conformity of the product. Key standards for laser systems include IEC 60825 for laser safety, SEMI S2, SEMI S6, and SEMI S14 for semiconductor equipment, UL 94V0 for material flammability, IEC 61010 and UL 61010 for electrical safety, and NFPA 97 and the National Electrical Code. Understanding how these standards apply is essential to a successful evaluation. In summary, laser safety requires a comprehensive approach that includes identifying all hazards through risk analysis, containing beam paths, through proper mechanical design, completing safety interlocking systems, addressing ventilation and environmental impacts, ensuring compliance with electrical and laser safety standards, and completing the evaluation process with proper documentation and certification. If you're developing a product that includes laser systems and needs support with the evaluation process, certification, or compliance with IEC, UL, or SEMI standards, contact High Tech Design Safety. We'll help guide you through every step, from risk analysis to final approval.